Exercise 6 follows up from exercise 5, the previous exercise. In the previous exercise, we used the same exact kernel on each of the three color channels of the image. And what I encourage you to do here in exercise 6 is just, have a little bit of fun and use a different kernel for the different layers. So, in particular, actually, I use the same general shape of the kernel. So it's still a Gaussian for all three layers. So it's going to smooth all three layers. But I've set the width of the Gaussian to be different for the three different layers. That's what you see here. So it's only a little bit of smoothing for the red channel, more smoothing for the green channel, and lots of smoothing for the blue channel. And there's no particular reason to do it this way. It's just, we're just having a bit of fun. So now we'll switch to Python and let's see what is the effect of layer specific or color specific smoothing kernels on the resulting image. So some of this code looks really similar to the previous exercise. And let's see, the unique part here is that we are creating the kernel inside this loop over each layer, over each color layer. So you can see it's e to the minus x squared plus y squared, where x and y come from this grid that I get from mesh grid. And then I'm dividing by the different kernel widths. And these are not numbers that come from any particular theory. I was just playing around and thought that these would be good numbers to use. Okay, so that means, I encourage you to play around with these as well and try different values. You can try different sizes of the kernel. Keep in mind that the larger the kernel, the longer the computation time will be. In fact, the 31 by 31 kernel is quite big. Most smoothing kernels are much smaller than that for reasons of computation time minimization. Okay, so then I'm going to visualize the kernel and then implement convolution. This now looks exactly the same as in the previous exercise, just that the kernel is unique to each color. Okay, so we can run this code and have a look. So here you see the three kernels, just like what I showed in the text in the book. And here is the image, and there's something that's like subtle and weird about this picture that's kind of hard to grasp. It's kind of hard to put your finger on exactly why this looks weird, but there's something that's slightly surrealistic about this picture, I find, in my opinion. And it's really driven by the fact that the different color channels are smoothed to different extents.